Okay, good morning, good afternoon, everybody, wherever you might be. Today we're going to be talking a little about Visual Studio 2010 testing capabilities for the developer's hands. Visual Studio 2010 introduced a whole new myriad of capabilities and technologies, and probably one that got the most focus was in the arena of testing. Now we did provide some new tools for the actual tester that exist outside the Visual Studio itself. But there are a lot of quality-centric tools that have been built into Visual Studio 2010 as well. And that's what we're going to focus on today. So here's a quick look at what we're going to run through. We're going to talk about some quality-centric tooling in VS 2010, some tools that sort of on both sides of the fence in terms of what can help you get your code right the first time before it goes over the wall to testing, and also some tools that have been revamped or introduced in 2010 to help you excuse me, to help you troubleshoot any existing issues that come up. And then depending on number of questions and the amount of time that we have left, I'm going to go through a couple other test-centric feature sets as well, specifically around web performance testing and UI automation testing. Now, to kind of get the ball rolling here, I'd like to just mention that we're really just going to be sort of touching the tip of the iceberg, so to speak, in terms of all the testing capabilities that are built inside Visual Studio 2010. So we'll be going through what I think are some of the most key concepts for several of the moving parts, but there are definitely many more layers, if you will, to the different topics we'll be covering today. So I encourage you to hang around until the end, and if you have any questions, feel free to ask them at that time, and I'll also be listing my contact information as well, so feel free to ping me for additional details or more depth in a particular topic. So one of the first things I like to talk about is the fact that testing isn't really just for the tester or for the QA. And there's obviously some testing that a developer or an enterprise developer might do, such as writing unit tests and validating data, maybe doing a little bit of analysis on their code. But that's sort of always been a sort of second-class citizen to the development process. That's something that Visual Studio is trying to change with this 2010 release and putting quality focused tools not only in the hands of the QA department but also the development team as well. So if ideally your code itself is as well optimized as possible before checking in source control and kicking it over to QA. What that does is it also then allows the QA teams to leverage their high-end development or testing tools that 2010 provides to help you provide a rich and more actionable bug. That is a bug that can be acted upon much more readily and immediately by a developer and has as much supporting and contextual information as possible. And so these tools really work hand in hand to try to bridge that gap between dev and test. So just a quick example of that, I liken this term to dev test ping pong, where you have the tester says, you know, I found a little problem, and the test developer would then say, well, it works fine for me, so what's going on your end? And it kind of goes back and forth. And the reason for this is that neither the developer or the tester have any tools that are well coupled together or are well integrated. So leveraging the platform of Visual Studio 2010 allows this sort of bridge to form between the dev and test departments to allow to sort of mitigate or minimize this amount of dev test ping pong to allow you to really get to the root cause of the issue and fix the problem much more quickly. So we're going to focus more on the right side of that ping pong table, if you will, today, more on the developer side. So here's what we're going to walk through, and these are the main moving parts around some testing tools that are built in Visual Studio today, which I'm going to talk about. For instance, on the first side of the fence, getting it right the first time, we're going to explore a couple tools around code analysis, getting code metrics, and a new powerful tool in 2010, test impact analysis, to help you, the developer, get your code to the highest level of quality while you're writing it. Because it's much more difficult to correct code and refactor code and make it as rich as possible well after the fact it's been originally written. So if you can get it better the first time, it reduces the number of iterations it takes to get the code to a production level, and it reduces the amount of overall time to market. And then secondly, we're going to look at things on the flip side of the coin, around diagnosing issues that have come up after the code's been written or pushed over to QA. And we're going to take a look at some really new powerful tools in 2010, especially Intellitrace, and we're going to focus on performance profiling as well. Again, if we have time at the end, we'll have a couple of demos which I'll throw in there too. Take a quick sip here. So the first thing we're going to talk about today is code analysis. Now, if you haven't used any sort of code analysis tools before, it's probably similar to what you may have heard of called style cop, FX cop, something like that. Really, it's sort of grammar checking for your code. It's checking at static or at design time, so it's not attaching to a running process or anything like that. It's actually looking at your code, source code itself, and looking for good quality and looking for areas of improvement, for things around naming conventions. If you're doing if you're introducing any sort of security hole by maybe writing inline select stars into your statements, looking for design issues and accessibility and localization issues if you are producing a localized or a globalized application. Visual Studio 2010 breaks up these rules, if you will, that it checks for into sets and into categories. So you'll have design categories, accessibility categories, naming categories, etc. And those will go into rule sets, which are a further large grouping of related types of categories and rules to run. These can be, or I should say, code analysis can be kicked off at any time by a developer and to exercise or to look at a project or look at entire solutions. However, it can also be configured to run anytime you just build your solution or build your project in Visual Studio. And that's something that's very effective, so you don't ever really have to remember to take that extra step to run code analysis after you build your project. And lastly, if you're using Team Foundation Server, and this really applies to almost any type of testing you're going to do inside Visual Studio, you can create work items in terms of bugs, issues, any item of record you need to track directly in Team Foundation Server from a result of your code analysis. So here's a quick look at the rule sets that come out of the box with Visual Studio. You have the ability to create your own rule sets. You can customize these existing rule sets, so you're definitely not bound by the quote-unquote Microsoft recommended rule sets that you can use. But effectively, when you're configuring for a certain project, code analysis, you're telling it, here's the set of rules that I want to, that are most important for me to use against my project. For instance, if you are building a globally accessible application, so you're building it to adapt to different languages and cultures, etc., you might want to turn on the globalization rules rule set, which will check for those types of issues when running analysis. You'll have some very minimum rules as well, such as the minimum recommended rules. You have a security rules rule set for looking strictly at security issues. And so you've got a good mix of all these. And again, you have the ability to not only create your own rule sets, but also create your own rules as well. There's a whole framework about how to tap an API to write your own rule sets when interrogating your code. So if you can customize this as much as you want to your heart's content. And we'll take a look at these in just a second. So if you think that is more on the qualitative side of things, another capability in 2010 is called code metrics, and that's more on the quantitative side of things. So this is actually looking at things like lines of code, cyclomatic complexity, depth of inheritance of your code at design time to try to measure and give you an idea, or give you an index actually, of the overall maintainability of your code in your application. This is obviously very ideal, but if this is going to be a long-running application or a long-running development cycle, or this is going to be something that needs to have maintenance done maybe 2, 3, 5 years down the road, you want to have your code as maintainable as possible so that someone else can pick it up and run with it if necessary. Or you could come back to it in a couple of years' time and have a better understanding of what's going on. So code metrics is something that runs to take a look at that overall complexity value and give you an understanding of just how complicated your code might be and how overall maintainable is it going to be if someone else were to pick it up. Code metrics is also provides results that you can also export to Excel. So I see a lot of customers do this. They'll dump it off to Excel and add a bunch of formulas to it and do charts against it as well, so that they can then save to a SharePoint site or send to their manager and say, look, here's where we're at today. Compare it with last week's data, and you can see that we're working on a refactoring process here, and we're getting more and more maintainable over time. So there are sort of 5 different pivots, if you will, that code metrics works off of. An overall one is the maintainability index, and that is really sort of built off of the bottom four as well. So your index will be basically a scale from 0 to 100, showing your ease of how easy it is going to be to maintain this code over time, where 100 is the high end of what you want. It'll also color code these for you as well to give you yellow and red warning.
Steve? Steve, are you there?
How many code? I just said I lost my audio connection, so I'll start over a second.
Okay.
So it shows it basically measures your overall structural complexity of your code and how many paths run through your program or from a certain scope, so a method, class, etc. So if you have a lot of if then else statements, if you have a lot of switches, if you have a lot of other options, a lot of functions, so there's a lot of different lines that a user could take or a line of direction could take through your application, that adds to your overall cyclomatic complexity. And that implies that there's a lot more unit testing you need to do, which overall makes it more complex to maintain over time. Depth of inheritance is pretty self-explanatory, but it basically looks at how deeply are you inheriting parent classes. So it gives you a number of how far up or how nested you are in inheriting your classes. So the deeper you go, the overall more complex that it is going to be managed over time. Class coupling is a little bit similar, and it measures the overall coupling to unique classes through different code elements such as parameters, variables, locals, etc. And generally, you want to have a lower level of coupling so things can be moved around and make it made as modular as possible. And then last thing is lines of code, and this is a pretty simple metric, as you can imagine. Historically, a lot of project managers have used lines of code as a way of measuring productivity, whereas now in the days of object-oriented programming, that's not necessarily the case. What lines of code does is effectively measures your intermediate language line code, or line count. So you see this value be slightly different than what you actually have in your source file. But just keep an eye on that as well. So that said, let me switch over to my demo here. Okay. So I'm in Visual Studio 2010. If you have not yet seen Visual Studio 2010, you'll see it looks a lot different than 2008. It's been rewritten completely in Windows Presentation Foundation, or WPF, so it's very responsive. It's using the latest and greatest technologies that we have for client applications. And it's very flexible, so you can move your panes around, you can break panes out of the actual parent window. You can do a lot of interesting things to help structure your development environment the way that is most productive for you. So first things first, let's take a look at an example of code analysis. So basically I've broken up a solution here for each of the little demos I'm going to do today. So the code analysis demo is very small and very simple, but and some of these things you might be able to notice just by looking at it, some things around naming conventions and signing and whatnot. But if you're not quite sure about that, or you've been assigned to run some code analysis, really all you have to do is you can run code analysis a couple different ways. You can go up to the Analyze menu and choose Run Code Analysis, or you can also right-click excuse me, on your project and say Run Code Analysis. So I'm going to go ahead and run my code analysis, and what it will do is it will build the project, then run the code analysis against that, and then it'll put any items that it finds, any sort of violations, whether it be a warning or an error, because you're allowed to actually weight the different rules as to whether or not this is going to be a big deal or not a big deal, and it'll put it in the error list. So you can see down here it found just one possible warning. Here's the code analysis rule 2237. It's a usage rule. It says you should add serializable to demo as this type implements iSerializable. So pretty simple and straightforward. If it's found in an actual source file and not in, say, the project properties, you can actually double-click on the code on the line, and it'll take you to that code. Now, that just found one thing, but just as a because I've done this before, I know there are other elements here that I maybe want to check for. So let me show you where you can set up your code analysis. You basically do that inside, let me close everything else out here. Inside your project properties, you have a code analysis tab at the very bottom, and you have a checkbox here for turning on and off your code analysis on build. And again, it's something I usually recommend you do if you don't have a compelling reason not to, because it'll automatically load code analysis for you every single time you Control-Shift-B. So for this project, I've currently selected to use the Microsoft Basic Correctness and Rules. So it's a pretty lightweight set of rules. If I want to see the specific rules that are in it, I can click on Open, and it'll show me here are the rules that it's going to be currently running. So there's Microsoft Design Rules, there's going to be usage rules, and here's some of the ones I found here. So serialization, constructors, etc. And you can see over here on the action that I can tell this to be a warning, or I can tell it to be an error based upon how important I think these issues are. What I'm going to do, just so I can show off a couple more things, I'm going to turn it from the light end, I'm going to do it up to the more heavily diagnostic end, where basically the Microsoft All Rules runs every single rule that comes out of the box with Visual Studio. So I'm going to go ahead and set that up and run code analysis again. And I should see more than just that one. And as you see, I have 13 rules that I found issues with. So there are some where it says I should correct the casing of test in the namespace by changing it to actual test. And there's a couple down here that are actually in my class file. Those are that sort of a naming convention one saying you should have an uppercase name when you're naming your type or naming your class. So if I click on that, I'll see that in fact I do have demo right here. So I can actually just quickly change that. And then I can, if I want to, I can either run the code analysis again, just to prove to myself that I did indeed fix that, or I can go ahead and say, you know what, I'm done with this one. Let's clear that one out, and I can suppress that error from happening next time. But let's go ahead and run code analysis one more time, and hopefully we should see that warning go away. And now I don't have that one there. However, it did give me another suggestion as what to do, so I should rename the demo to end with exception because it is an inheriting exception. Okay. So next little demo let's walk through is on the metrics side of things. So the code metrics demo is is using something that's pretty simple, just to kind of, as an illustration. So there's a little class library. I've just got a couple functions in here. One which says just returns a single letter, and then I've got one that's slightly more complex. I mean, simple for everyone to read, but in terms of code, it's a little more complex. In that it says it returns, it's going to return a letter value based upon the current second of the current time. And so you can see that kind of runs through things a little bit. And if I go ahead and right-click on here and I say calculate code metrics, I get it in my code metrics results window. You'll see it gives me sort of a hierarchy of what of where I'm looking at, and I can see now I've got some maintainability index. It's currently set to 65, which isn't bad, not great, but not bad. Class 1 itself, this might look a little bit confusing because you're looking at, if you look at class 1, this is actually the constructor. This is actually the class itself. So the overall class 1 is a maintainability of 65, but the class 1 constructor is 100 because there's really nothing in it. The simple give me a letter is the one that actually returns a bunch of items. I go ahead and select that to open it up. Has a relatively low maintainability index because it does create a lot of paths to go through because I'm using a switch statement. And the single one is very maintainable because it only really has that one path through it. And you can see that by looking at the cyclomatic complexity column. So there's really only one code path for the give me a letter 1 function, whereas if I look at the one that has a bunch of switch statements, there's currently 11. So remember what this looks like with 11 and 51. And if I go ahead and I go down to somewhere in here and say I want to make this just a little bit more complex as well, I can add in maybe another 5 or 6 as well. And if I rerun code metrics, it dropped another 5 points. So my cyclomatic complexity went up by 5 from 11 to 16 code paths, and my maintainability index went down from 51 to 46. And you see that it also has affected my overall maintainability index for my class 1. It dropped it down to 61. And that's because I did add an additional 5 or 6 code paths through that method. So again, just something to keep an eye on. It really just helps you better understand I guess you could call it the level of spaghetti that you might have in your code, and to give you a chance to kind of clean that up before you go ahead and commit that over to QA or commit that for the performance level testing. The ability to filter as well, and you can also filter by min and max values. So if I want to say filter by overall maintainability index, or say I want to say show me just where cyclomatic complexity is at least 10. It'll filter that down for me, so I can, if I don't want to worry about the things that are 1, I can filter out. So now I'm just looking at the items that have a complexity of over 10, which is 16 and 18. Okay, great. This is a test impact analysis is a new capability of Visual Studio 2010, and I think it's a tool that isn't used very often, but I think that the more people use it, the more integral it becomes to their development process. If you're actually pretty regimented about using unit testing, which is, if you're not familiar with unit testing, it's basically a way of exercising certain elements of code, at the method level, to ensure proper behavior in terms of input-output. Test impact analysis helps you identify the exact tests or a suggested list of unit tests you should run as a result of code changes you've just made. This makes a lot of sense if you're doing a lot of unit testing. So if you're working on a solution or a project that, say, has 1,000 unit tests, I've seen solutions that have upwards of 10,000 unit tests. Let's say you have 1,000 unit tests, and you're not terribly familiar with the code area that you're working in, but you do make a few changes to the code, and now you want to understand, I need to make sure I'm running some tests to make sure I didn't break anything on the other side. If you don't have an intimate knowledge of the unit tests that were written against those, you do not necessarily know which tests you need to rerun. So most people will just punt and say, you know what, I'm going to rerun all my tests. And so rerunning 1,000 unit tests just to validate, maybe 2 lines of code that have changed, is a lot of overhead, and it takes a lot of extra time. So test impact analysis looks at the code changes and says, when you ran these unit tests, it exercised that line of code. Now that line of code has been changed, so I think you should probably run this one again. It saves you a lot of time as you go through your iterations in development. So let me switch back over to my demo here. I'm going to go ahead and look at my test impact demo. Again, it's a nice little class library. Doesn't have anything too fancy to it. There's just 3 methods. One just capitalizes a letter that comes into it, one that just says hello based upon the time of day that it is, and one that just adds 2 integers and returns a value. I also have a unit test to capture that. I'm going to go ahead and get rid of this guy. I don't need that one yet. Little guy. Okay. So I've got 3 tests here, 3 unit tests, one for each of these methods that I have. I want to say look at a certain test. I can look at, say, hello time of day test, say good morning. It's actually the afternoon, so I want to make sure that this one's going to pass. And so now if I take these 3 tests and I just run them, I just want to make sure that they're passing. See, my test results window pops up, starts pending the tests. Okay, and it shows they've all passed just fine, so that's good. So now let's see what happens if we make a change. I've got a test impact window over here as well. It says there's nothing that's been impacted by any changes I've made. So if I want to go ahead and make a little change here, let's change this time of day. We'll say something like, instead of good night, we'll say good late evening, just so I have a small change that's been made. Now the test impact analysis kicks in every time you build. So I'm going to say go ahead and let's build test impact demo. And now what I'll see over on the side is in my test impact view, I've got an area that says impacted tests. And so now I've got that unit test, that say hello time of day test, which says that this was exercising the line of code that you changed before. So this is something you might want to run again. So it's very simple for me to do that. I don't have to even switch views back over to my test view. I can simply just select this test and say run this test from here, run the selected test. And it'll run it, make sure that everything's going to pass properly. And once it passes, it's removed from the test impact view. I also have the ability to look at things such as show me the exact codes that's been changed if I did have an impact. So if I were to make another little change here, say change it back to just good evening and build this again. So there's that impacted test again. And I can also say, based upon the impacted test, what code has actually been changed. So I can go the other way as well. If I'm not starting with my code open, I'm coming in from a test mindset, I can actually look and see here's the actual methods that have been changed, and I can actually say run all the tests that have impacted this method, or go actually take me to the definition of that method. And lastly, I can look at all the tests that might call other tests that were impacted or not impacted. So it's a great time-saving feature. If you think that in this case it was a pretty simple scenario, and I only had 3 tests to worry about and filtered down to 1 for me, that's a little bit of help. But ideally, if you have a lot of tests, like 10, 100, 1,000, 10,000 unit tests, and you're making this one line of code change that I just made here, this will dramatically help you reduce the amount of time it takes you to go and verify this by running unit tests. Okay. So let's jump back over to here. Make sure we're still up. Here we go. So make sure we're all in the right place here. Okay. So that's all. Those are some of the things you can do while you're actually developing your code, while you're actually filling out your functionality of your application. Now, there undoubtedly be some things that slip through the crack that don't pass, that maybe do pass a build verification test, but don't pass a test case analysis or requirements matching against that. So that comes back. So now there's some tools that will help you diagnose some existing issues. First of all, there's a new tool called Intellitrace. Intellitrace, I try to explain it as sort of debugging on steroids. Current debugging is perfectly fine to use, especially for those who are very knowledgeable how to use debugging and setting breakpoints and watches, etc. However, its main drawback is it's historically been forward only. So if you're trying to debug why a value is being returned incorrectly, and you're trying to drill down to see where that's taking place, either spend time hitting F10 and just stepping through the application each time and keeping a watch on that variable until it changes, or you're setting a breakpoint at a certain place and running to that spot and then checking the value of something. And this happens all too often for me and for I think for others, is that you set this value or you set this breakpoint, you run and it's maybe just a couple lines too far and you've already seen the wrong value. So what you do is you pause, you break, you reset the breakpoint, and you hit F5 and run it again. You kind of go through the cycle until you finally narrow down the issue. Also, debug logs are something that's not readily creatable by an actual tester or a non-technical tester. So when that person is running their test case and they come across an issue and they file a bug, it comes over to you, the developer. There's not a lot of code level context behind that. There's only the screenshot or the description from the tester saying, hey, this broke, or hey, 5 plus 5 did not come out as 10 when I entered it in the calculator, or something like that. So enter Intellitrace. Intellitrace is new to 2010, and it's really sort of like a TiVo or a DVR for your debugging session. What it does is it dynamically goes through and instruments your code as you're executing in debug mode, and sort of records what you've been doing and the state of your entire application, both the events and calls, etc. and you're allowed to then pause and go backwards if you like to any different point, to any sort of event or call. Say at that point in time, what did the state of my application look like? This is also a very powerful way to kind of, again, sort of work on that bridging the gap between dev and test, and that some of the testing tools that Microsoft provides for the non-technical tester will automatically run Intellitrace behind the scenes. So when they come across an issue and they file a bug, this Intellitrace log file that automatically gets created, it's called an iTrace file, automatically goes along with the bug so that I, as a developer, I can simply open up that Intellitrace file and I'm immediately taken into a debug session that they recorded. And I can, if I have access to the source code, I can navigate through the source code as I click on different elements in the log. And so we'll take a look at what that looks like right now. Go over here. Open up my Intellitrace demo here. Really, all this does is it's a simple Windows Forms app that you just put in a first number and a second number, and it can add or subtract them together. So just to kind of show you an example of what that looks like. For instance, say I'm now testing this. Maybe someone told me that the addition works, but the subtraction doesn't work. So if I want to test this out, I can say, 2 plus 3. If I hit add, is actually 5, and so that's good. Now let's say I want to try this different number. Say 5 plus 4 is 9, and that's good. But I know 5 minus 4 should be 1. If I hit on that, I still get 9. So I know that there is indeed a problem here. So what I can do is, you'll see on the right, there's an element here that says in my Intellitrace pane. I'm going to go ahead and hit break all, and what this will do is it'll basically break the execution of all the threads for this application, and it'll give me basically what it's found in the log and what's recorded along the way. So basically I'm looking at a step-by-step of what's happened so far in this application. I can see gestures where a human has created an interaction, so I've clicked on an add button, I've displayed things, etc. I can see here I did an add again. And down here as well I can see that there's a gesture where I clicked on subtract. And now since I know that the add worked but the subtract caused a problem, I want to take a closer look at the subtract. And I can see where the user clicked on that. It says the user clicked on the button with the context subtract in the main thread. If I want to go ahead and switch and say, now let's see, how did I get down to this area here? I can now see that here's that gesture here. I can see that the gesture actually translates down to this button subtract click event. I can click on this expand button, which shows me all the events that occurred below this point. And now, if you look on the left, I'm actually getting into some real code, not just the application run anymore. I'm actually looking at the button subtract click handler. And I can look even further down here and say, here's the flow of what happened. If I click on get number 2, and then here's where it actually did the subtractions. This subtract integers, where it says num1 was 5 and num2 was 4. I want to click on that, and now it's actually going to go ahead and if I expand that a little bit, it actually takes me into the do the math class, and I can now look into the exact code. I'm drilling all the way down to see what happened. So I can see that this is the bottom of the call stack that I was, or the call tree that I was, where I started looking at the problem. So I realize all I've got is an entry and an exit. So I know somewhere in here it broke, and sure enough, I can see right here that instead of subtracting them, I'm actually adding them. So this is obviously a very simplistic example, but you can see how you can use the call stack and use Intellitrace logs to drill through very quickly by not having to worry about the program flow necessarily, but looking at a little more of a natural flow perspective of what's taking place when you're running through an application. So I can see gesture, I can see user prompts, I can see pop-ups, I can see everything like that, and that helps me better understand correlate from what I was doing in the application to where things were going wrong, and I can drill in much more quickly and much more readily. And again, this is something that can be captured, that is captured if you configure to do so automatically when you're running in debug mode. You can also configure what level of detail you want to capture. Do you want to capture just events plus calls, external information? You can configure all that sort of stuff. And you can also, again, have the tester who is running, say, Test Manager or Test Professional from Microsoft, have Intellitrace logs automatically generated when they're exercising an application. So when that comes over to you, you can jump right into their debug session using that Intellitrace file. Okay, let me close all this stuff out here real quick. And let's switch back over here. Thought I'd done that. There we go. All right. Second area around diagnosing issues, and this is primarily around performance-based issues, is the profiling tool inside of 2010. Profilers existed since the 2005 release of Visual Studio, but it's dramatically been improved for 2010. We've added different types of elements that can now be captured and traced. Performance profiling is truly as it sounds, for looking at performance issues and trying to diagnose where they are, so you can fix those and optimize your application from a performance and usage and RAM CPU perspective. So first of all, when you run performance profiling, it creates what's called a performance session. A performance session is where you configure what you want to be collecting when you're attaching the profiler to your application. So in terms of what performance counters do I want to capture? Do I want to be looking at concurrency issues across multiple threads? Do I want to take advantage of the new tier interaction capability in 2010, where I can actually look at database calls and their specific statements that are being made in communications between a service and a database? Also, do I want to take a look at client-side JavaScript that might be running as well? And you run basically as many performance runs, if you like, within a performance session. You can compare and contrast those, and you can take advantage of some capabilities called hot pathing, as well as the overall reports. Reports can be shared, they can be exported, so you can do a lot of collaboration around examining a specific performance issue. I think rather than showing you a couple of screenshots of these, which are here, I'm going to go ahead and just go into a quick little demo and show you some performance profiling. So let's go into performance profiling here. I'm going to go ahead and make this my starter project since I'm done with the other one. And really all this one is, this is a command line application. That's all it's going to do is run through and call three different methods. One which will aggregate ticks, so basically it'll basically count through just an integer or a long value and add up those numbers and give it back. There's also a get messages, which uses a link to SQL call and just gets a list of message objects from a database. And there's one that gets a specific message as well, so it matches up the message ID in the database. So if I run this, you'll see it's pretty simple and straightforward. All it's doing is outputting, and that's done. Now that was fine, but it wasn't great performance. Now we want to take a look at that application and see if there's anything we can do to improve its overall performance. So what I'm going to do is I'm going to go up to Analyze. I'm going to say Launch Performance Wizard. The wizard is a great tool for kind of helping me get off the ground and guide me through what exactly do I want to accomplish by profiling. So I can choose my method. So I use some different types of methods here to help me better understand what I'm looking for. So for instance, this is the basic profiling method that's suggested. It's called CPU sampling. So really all this does is just attaches, and every few milliseconds it taps into your process and says, where are you in the application, and how expensive is everything going, and what's your garbage collection look like, etc. You usually use sampling to help give yourself an idea of the scope of where the issue might be, and then you further diagnose that by adding instrumentation. So this measures all your function call counts and their overall timing as well. So I'm just going to do instrumentation so I can see what there is. Looking at my solution, says here's the different ones I could run it for. I'm going to do performance profiling demo. And I'm going to go ahead and tell it to launch when it's done. So it's going to go ahead and run my app again real quickly. But while it's been doing that, it's also been profiling behind the scenes. So when it's done, what it does is it actually compiles a performance profiling report for me. I'm going to go ahead and take this to a fuller screen so everybody can see that. And it gives me a nice little profiling report. So it says here's how long it ran, so a little over 3.5 seconds. Here's my CPU usage over the course of that time. If I look down here a little bit further, I have a hot path. The hot path tells me this is the most expensive call path in terms of execution time. So I can see as it kind of drilled down, read line took a long time, probably because I took my time to hit enter. This get messages call took 41% of that time. And then I look down at the most expensive functions. So these are showing the most exclusive times taken up by individual items. So I can say here's one that's actually in my sample class. Maybe I'd want to take a look at that, see if there's anything I can do to improve it. You can filter these, by the way, so you can filter out, by namespace. I can say I don't really care about the system dots. I just want to know about my only code, and so there's a filter that allows you to set that up. I can also filter based upon different functions, a call tree, details, and specific processes. So if I'm measuring across threads, I can choose a specific thread to look at as well. You'll see all these are hyperlinked, so I can actually say click on aggregate ticks to, and it'll take me to a little more of a detailed look in the report where it shows me here's my distribution, here's methods that called it, and here's the function body, the bottom of it as well. And down here at the bottom, it's also showing me the actual source code too. So I can see here's the aggregate ticks too. So if I click on one, it'll say here's my read line, here's my get messages, etc. I can kind of navigate this back and forth. And so you see I'm getting a lot of detail in just one report file. So this report file is very powerful, and it gives me a lot of insight as to what's going on. So if I see that, for instance, there was a CPU spike right here for the first second and a half, that's because it was cycling through the ticks that I'd set up. I can actually filter this by simply just dragging and going across this boundary. And if I click on that, oops, select that, then click on filter by selection. Oops, I closed it out. Sorry about that. You'll see it actually zooms things down to the specific time frame that I've selected. So now I'm looking at a little over half a second rather than the full 3.5 seconds. Now, what else I'd like to show you is see if over here there's a Performance Explorer panel. The Performance Explorer panel keeps track of my current session, which is marked up here, and anytime I actually run a profile, it's going to create a new report for me, and it tells me here's what I'm running against. So if I were to make a change to this and run this again, you'll see that I can actually compare the performance sessions over time. For some reason, it's not letting me open up now. So let's go ahead and close this real quick here. And my little double click stopped working for some reason, so we'll just launch this again real quickly. Here we go. So let's go back to this. Let's see if I can get through this guy again here. So let's do a performance session here. Let's do sampling to make it quick. Launch this. We'll run it one time. And then I'm going to make a little change if I can and run it again. All right, so that's good. There's my report as it loads. What I'm going to do, open up the code. And I'm going to change this value from, what's this, 1.5 million down to 5,000, just so I have something a little bit lower. Ideally, it'd run a little bit faster. So let me build that. And then what I can do is I can come back to my Performance Explorer and run this again. So I can profile it a second time. This time I'll run a little bit faster. You'll see it creates another report, and I'll see another report shows up in this list as well. So now I can actually take these two reports. If I'm trying to benchmark and see if what improvements I'm making, I can right-click and say Compare Performance Reports. And we'll open up both of those side by side. And I can see, based upon, here's the two things I'm comparing, what actually am I comparing? I'm comparing functions. So there's the aggregate ticks. I can see it improved by 15. So I had this baseline value here. So it's actually dropped down. So I'm actually seeing some improvements here. Maybe a couple things are getting a little bit longer. Could be due to all sorts of different reasons, though. But the idea here is that you can compare your performance reports over time and see if the tweaks that you are making is actually making an impact or not. So again, a very nice capability to have. It's something that's included in Visual Studio Premium and Up. Okay, so we do have a little bit of time left, so I will show you a couple other little things that we have. This is something that I see a lot of testing departments will set up, but this is something that just as readily be set up by a developer. And this is similar to, I think it's almost like a unit testing, if you will, for a web-based application. A web performance test, this is not something new to Visual Studio. In 2008 and 2005, it was simply just called a web test. But in 2010, we renamed it to a web performance test because it truly is more headless, and then it's really kind of measuring your overall performance at the protocol level, at the HTTP or HTTPS level, rather than checking overall functionality. So it looks at your response time, any server return codes, missing resources. You can add a lot of validation to your test to make sure that maybe look for a certain string inside your HTML, or make sure a certain HTML has a certain tag on it. And I think just as powerfully, this can be data-driven as well. So let me show you a quick example of what that looks like and what you might want to use that for. So I've got a web-based project here, and it really is the sample ASP.NET application with just a little simple add calculator on here. So if I click on calculator, just enter my first number, enter my second number, hit add, and down the result I should see that I have 3. So that's great, but say I want to see how well is this actually performing, and I don't want to have to just do this on my own every single time. So what I can do is I can go ahead and just create a new test by saying add web performance test, and you'll see what I get is it's actually going to pop open Internet Explorer for me and put a little pane on the left called the web test recorder. And now basically this is ready to record everything that I'm doing in my application. So I click on home page, takes me to the application. You'll see it actually already grabbed the page that I went to. I click on calculator. Now let's grab the calculator SPX page. I'm going to add 3 plus 4 and hit add. You'll see now it captured the form post as well and all the form post parameters that went with it. So you can see here's where I added 3, I inputted 4, and the button itself. Now I can see that looks great. So I can simply hit stop. And again, I'm really scratching the surface of what you can do with this here. But if you really just want to have a quick automation test to make sure that what I'm doing is correct, then this is a great way to do that. So what it does is after you finish running the test, it reruns the test on its own to check and see if there's any parameters in your test that can be set to be dynamic, which means that, if you're testing it's a web farm and you dynamically choose different web servers to go to, you can do that. If you need to, if you want to set it up so that you can run run against different values instead of like the 3 and the 2 or the 3 and the 4 that I put in, it works just fine. So for instance, now if I run this again, you see down the bottom it's running the test. Let me move this up just a slight bit. It shows pending, in progress. I can actually see the test running. Notice it's not popping open my browser for me. It's actually just running it headlessly for me. I'll let this finish running. Okay, and that passed. So for each step, I can actually click and see what the web browser saw when it came back, request headers and whatnot, the responses that came back. I can see the raw HTML that came back, so I can see here's that result. When I added 3 plus 4, I got 7. I can look at contextual information, and I can see any additional details as well. So if I added any validation rules, which says go and make sure this page came back in sub-second time, it would check for that as well here. So in this response time goal, it's checked to make sure that it was responding in a certain time period. Now let's go ahead and jack this up one notch, and let's say I wanted to exercise this with more than just the entering 3 and 4, but I want to add some different values as well. What I can do is actually add a data source to parameterize and data drive this as well. So I'll say add to numbers data source. I pulled this in an XML file. I simply can browse around for a file that might contain. Let me first just show you what this looks like. It's a simple XML file. You can notice that I can grab a CSV file or a database table as well. I just got an XML file saying here's number 1, number 2, and their overall sum. So I've got 3 different entries here that I can play with. So I'm going to select that one. It interrogates the XML file, says is this what you want to use? Here's what I found. Here's the table in there that I want to use. And basically say yes, please add it to my project, so that when I deploy and run this on a separate machine, it'll deploy the data source with me. And now if I run this test again, I actually didn't wire anything up, so it'll still just run one time. Let me go ahead and stop this test here, just in the interest of time. So now what I do is, you see I have this pairs table with me. I can take this and I can go to where I actually posted that form. You see now where I had the first number is 3, second number is 4. I can actually look at the properties of each of those and see where it says value equals 3. I now have a drop-down list, and I can choose from existing data sources that I've added. So I can say I want to use number 1 for this one. I want to use the num2 value for this one. And then I can add it from there and let it run. Now if I wanted to, I can add some additional validation to make sure that the result equaled the sum value. But basically what I've done now is, since I have 3 sort of data sources or data rows that I'm passing through it, instead of running 1 time, it's going to run 3 times. And it passed. So you can see for each run the different values that was passed through. So I can look at this one and show, looking at this one where it passed out, see here I added 4 and 5. This one where I did 10 and 7, and then this one where I added in 1 and 3. So you get the idea. So anyways, it's a great way to data drive the web performance test. So I can, if I want to, hook this up into a load test as well to really stress my web application and see how it behaves. Okay, I'm going to show one more thing, and then we'll be ready for some questions if there are any. The last thing I want to talk about, and it's really something that I think is a very valuable capability that's been added to Visual Studio 2010, is the notion of what's called a coded UI test. That's Microsoft's terminology for saying a functional UI test that's represented in .NET Managed Code. This allows you to validate the actual functionality and behavior of the application rather than the underlying performance or interaction. You can create a coded UI test simply by letting Visual Studio record your actions, record your interaction with the application, and then turn that into code. Or if your development or your testing team is using Microsoft Test Manager for executing their test cases, it can also take recorded actions from execution of those test cases and turn that into code as well. That's really valuable in helping diagnose an issue that the QA person comes across. If they're running through a web application and they see that those numbers didn't add up correctly and they file a bug, the recording that was being generated underneath the covers while they're executing their test case can also go along with the bug, and then you're allowed to then, as a developer, take that recording and automatically generate a coded UI test from that, and then you have a much more code level intimate knowledge of what's going on in that application. So let's take a quick look at what that does. So you've seen what the little web application looks like. I'm going to go ahead and add now a coded UI test. And now I'm not really checking for performance, I'm checking for overall functionality. So the first thing I get is a pop-up that says, how do I want to generate this coded UI test? Do I want to record my actions or use an existing recording? I want to go ahead and record some new actions. So what it's going to do is it'll clear the screen out for me. And in the bottom right pane, you'll see there's a little coded UI test builder panel, a little applet that's running for me. This allows me to just kind of stop, pause, record, add assertions as I'm going through this. So what I'm going to do is I'm going to start my recording. I'm going to go ahead and fire up Internet Explorer. And you'll see it's actually popping up things as I record what I'm doing. So it says click on Homepage button. I'm going to click on Calculator. I'm going to enter my first number, enter my second number, and add. And see, that looks good. So that's one way to look at it. I can now, if I wanted to, I could generate that entire interaction into one big recording. What I want to do differently, though, is show you in a different example of this, and I'm going to go ahead and make it a little bit better structured. I'm going to create a code UI test, and as I'm going through, I'm allowed to pause the recording and say, what I've done up to this point, I want this to be one method in my code. So let me go ahead and close this and start over. So I'm going to record this again. So I'm opening up the browser and going to the home page. Maybe I want that to be one method, saying first thing I want you to do is open up the browser, go there. So open to website, I'm just going to call that, and now it's going to generate an actual .NET method called that, which is going to basically reproduce opening up Internet Explorer and navigating to that URL. And when I'm done with that, I can say continue recording, go over to calculator, and I'll say enter the first number, which is 5, enter the second number, which is 4, and I'll click add. And I'll say that looks good, so now I want to say go to calc and enter numbers. Now I'll add that code. Now what I also want to do is I want to add some validation. I want to make sure the result is actually equal to 9. So I can take this crosshair little icon here and I can drag it around my screen, and you'll also see as I'm moving around the screen it's grabbing the different elements and containers that are in my application. So this allows me to drag the crosshairs over what I actually want to measure. In this case I want to just measure this label that has the word 9 in it. And so it basically does an interrogation of that control that I'm on. It says this is a label, and the display text currently is set to 9. So that's what I want to assert. I want to make sure this actually equals 9 when I do 5 plus 4. So I basically said add assertion. I'm going to make it an R equal and make it compare against 9. And then I can hit generate code for that too. I'll say assert result. Make it nice and generic there. And then the last thing I'm going to do, just as sort of a point of housekeeping, I'm going to tell it to continue recording and then actually watch it record me closing out the browser. This allows me to do a complete end-to-end test. So I'm going to add and generate, and then I'm going to say that I'm done. So by clicking on the X, it takes me back to my code UI test, and I can see now if I go to my code UI test method 1, I've actually got those 4 different methods that I've created. So I can actually now right-click and run test. And this is the part where I wish I had a webcam to show you I'm actually not clicking anything anymore. You'll see it's actually just compiling the .NET code. You'll see it pending now in the test results window. And as soon as it shows in progress, you should see Internet Explorer open and it kind of run through what I did. So I'll let that fire up. So just open them there. It's simulating now clicking on homepage, clicking on calculator, entering my 2 numbers, add, ran the assertion, and it passed, and you see that it closed the browser for me. So this is a great way for me to do some good end-to-end automation testing of my application. And I can data bind this as well, so if I want to run it through those pairs again, I'm happy to do that. You can bind different coded UI tests together and really kind of create a much more elaborate type of automation test to go through your entire application, all within Visual Studio. Okay, that said, there were a couple things that we weren't talking about today, and I knew we'd run out of time, so they're not necessarily developer focused either. The load testing capabilities inside of Visual Studio. This allows you to really ramp up and stress your application with multiple thousands of users. And also Test Professional, which includes Microsoft Test Manager, which is really our test case management and test case automation tool for the more generalist type non-technical tester. So there's lots of information on the web around those 2 tools, and so I'm happy to share that if requested. So to just wrap up, and we can take a few questions since we're right on the mark at 1 o'clock Pacific. Just to kind of close the loop here, so Visual Studio 2010, it has a lot of new capabilities which are what I call quality-centric to the developer. So they're tools that are built into Visual Studio IDE itself for the developer to take advantage of to help optimize his code quality as he's writing it, and to more quickly help him diagnose and fix issues as they come up. And the couple of the bridge gaps here, especially by leveraging Team Foundation Server and Intellitrace, really allows the QA team to be much better aligned with the development team. So you get the idea of getting that rich and actionable item sent across your desk where you can fix and mitigate the issue much more readily than you could before. Okay, that is said, Amanda, if you like, I'm happy to open up to questions.
All right, awesome. So your first question is from Mike. Is it possible to run performance counter in a daily build automatically? For example, starting within the MS build script.
Yes, you can. You can execute performance sessions and performance profiling from a command line. So as basically, it's depending on the version of Visual Studio you're using, it's either going to be a little MS task you just call out, or if it's part of, say, a larger Team Foundation Server build automation, it's simply an external activity you add into the build workflow. But yes, you can definitely do that.
Okay, and from Ron, can the app be packaged and sent to a tester with Intellitrace and also work for web testing?
Intellitrace does work for web testing. In terms of being packaged and sent to a tester, if you're using Microsoft Test Manager, there's no need to package it because Intellitrace is already included in that product as well. So whenever they're executing a test case using Test Manager against any application, it's going to be automatically recording Intellitrace.
And from Ron, can you mention how to test with various browser versions?
Oh yes. I'm assuming we're talking about the web performance test. The web performance test comes with definitions for, I think, 8 or 9 different browsers. It's really a matter of just choosing the browser that you'd like to use. You can actually add in your own browser. Really, all you're doing is, since it's headless, is customizing or defining what header information is going to go to the web test API as it's executed. So I'll go ahead and bring that up real quick as well. So I'll go up here. For instance, web. So here's the different types of browsers which come out of the box with Visual Studio 2010 you can add. Of course, you're welcome to add your own as well.
Okay.
Okay.
Let's see. Is Code UI feature in Visual Studio 2010 Pro, is there some possibility to record UI actions in runtime on the customer side?
Great question. So the coded UI test or the recording actions in at runtime on the customer side is kind of an expensive operation to do. It's not something that is really sort of recommended to be done. It is something you could tweak, but you actually have to ship with your application a lot of, say, the Intellitrace options as well. In terms of recording UI interactions, it's not something that's out of the box. All the APIs are there if you want to do it, but I don't know of anyone that's actually done that.
Okay.
And if you'd like whoever asked that question, if you'd like further clarification, please send me a note, and I'd be happy to provide more details.
Okay. I will. What is your email? Oh, yeah, there it is.
Yep. I'll put that on the screen for everybody who wants to jot it down.
Okay, we have 2 more questions. Let's see. Is it possible to get the source code from your presentation, Steve?
Oh, sure. Yeah, it's nothing fancy. So what I'm going to do is probably in the next couple days, I'll post when I post the slides that I use for both today's presentation and the Team Foundation Server presentation I did on Tuesday, and I'll be happy to post the actual source code up to my blog as well. So look for it. Just go to the blog address, which is listed there, or you can search for my name. You'll probably find me pretty quickly, and I'm going to put a post entry up there soon.
And then Ron is asking if you can talk about load testing, simulating multiple PCs under loads.
Sure. So load testing works a couple different ways. One is with Visual Studio, it's a hard-coded limit. You can actually run on your own individual PC up to 250 virtual users at a time. Now, of course, a lot of people want to simulate more than that type of load. So we provide what are called load controllers and load agents. And basically acts as a sort of master-slave or load distributor, whereas you can define or you can install these load agents on different machines that are sitting idle or you're ready to use as part of a distributed test. And then when you're creating your load test, you're specifying user mixes, how you want to actually do virtual user testing. Do you want to do it based upon user pace? Do you want to have 70% of your virtual users do one test and 30 do the other type of test? So you have a lot of options of how you set that up. And then the load controller, which basically becomes Visual Studio, helps determine where to order the load off to different machines. If you're testing more than 250, 300 users on one machine, we usually recommend you split it up, because that at some point then your resources on your physical machine are going to become more of a hindrance and sort of I should say adversely affecting the load results of your test. But there's so I think that was Ron asked question. Ron, feel free to send me a note, and I can send you some more information on how to set up and how to run distributed load tests.
Great. Well, that was your last question. So.
Okay.
We'll go ahead and wrap it up. And thank you so much, Steve, for being here 2 times this week. We enjoyed having you. And
no problem.
Everybody,
thank you very much.
Absolutely. Our final webinar of the week is tomorrow morning at 10 a.m. It's ASP.NET MVC3 with DevExpress extensions with ASP.NET evangelist Mehul Harry. Learn about the new DevExpress MVC3 support, including new project templates and how to work with the new Razor engine. We have a great lineup of webinars scheduled through March. You can register online at devexpress.com/webinars. And again, if you missed anything from this webinar or you want to review any previous webinars, you can visit us on the DevExpress channel at tv.devexpress.com. Again, thank you so much, Steve. Thank you all for joining us, and thanks for choosing DevExpress.
Thanks, everybody.